Hi, this is Zixuan Jia. So for the first question, we know that omega n represents n squared, n cubed. And for big O of n squared, it represents 1 n and n squared. So we can see that these two functions belong to both of them. So I chose true. So the second one, we know that big O of n squared equals to, like, it represents 1 n and n squared. So like big theta of n is actually in this, so I chose true. Okay, so for third one, if a function is in omega n, then it is always in big O of n. It is actually false because omega n represents n and squared and cubed and so on. But big O of n only represents 1 and n, so I can see that some are not like in big O of n, so I chose false. Okay, so for this one, I can easily see that this is merge sort because like for this array, I can see that the first half is actually sorted, and for the second half of the array, like this part and this part are all sorted. So this is like obviously merge sort. So it is not selection sorts or insertion sorts because if it is a selection sort, the second number it will sorts will be the number 1. So like before 2, the number 1 will like be sorted before 2. So it is impossible for like selection sort to have 1 not sorted, but like number 2 is already sorted. Okay. So for insertion sorts, when we move to the number 6, and number 6 will like move forward to go before 7. But for this array, 6 is actually like moving back. So this is also impossible for insertion sort. Therefore, this one is merge sort. So for this one, firstly, we will like figure out the recurrence relation for this one. So firstly, we can analyze the recursive parts. So for recursive parts, we can see that there are 2 recursive calls, so it is 2 times. And then we can see that SS is like getting is times 2 for like each iteration. And then until it reaches like n, so it is the same thing as like n divided by 2, and then eventually it will get like n equals ss. So these are the same thing. So when ss times 2, it is actually the same thing as n divided by 2. So in the question, it only asks respect to n. So I'll write like n divided by 2 here. And then for the non-recursive parts, I can see that here's a for loop. So for for loop, like I can see the upper bound is n. So I'll just simply plus n here. And then I can also see like some constant steps. So it will happen like in each iteration. So there are also some constant steps. So this actually is the recurrence relation for this one. So for the recurrence diagram, so for this case, I will use like n equals to 4. So firstly, we have like the level 1. It will only have like 4, 1. So this is the first case. And then for level 2, if you get to like g of 4, 2, there are two of them. Then for level 3, if you have like 4 of g of 4, 4. Okay. So because when SS is greater than n, like it will like stop. So for this one, it actually have like the final level, which is like g of 4, 8, and so on. There's total like 8 of them. So for the non-recursive work, we can easily see that like for this one, when n is equal to 4 and SS is equal to 1, the for loop will actually like run 4 times. So non-recursive work like here is actually 4. And also I have some like constant steps. So I plus some constant. And then for level 2, when n is equal to 4 and SS equal to 2, then the for loop will run actually 2 times. Then plus some constant. This one is also. Okay, so for this one, the for loop only run once. And then for the final like level, it's actually like run constant times. And then we add up like each level, so we all get 4 plus c's. So then we can come out that because like in my case n is actually equal to 4, so the non-recursive parts will actually be n plus 1 because we use 1 to represent constant steps, and then n is just the total work done by the for loop. Okay, so that's it. Thank you.